Dear students, I am Nilanjana Sanyal. Welcome you all to my channel Learners Online Math Classes. Our today's topic is rewriting expressions in terms of a given variable, which is a logarithm. Now, the expressions that will be given to us may be pure algebraic expressions which do not contain any log term, or they may be containing log terms as well. They may be containing a single term, they may be containing multiple terms. And we have to rewrite those given expressions in terms of a given variable. And do you find this part a little confusing? Given variable and within brackets it is a logarithm. What does this mean? Like if you can have let t equal to log of 5 to the base 6. We can have this, let t represent log of 5 to the base 6. So if I write this, and whenever we have to write log of 5 to the base 6, we can write t. It will be much easier, less time consuming, less space consuming, so less error prone. So that is what is meant by this part. We have to rewrite expressions in terms of a given logarithm. But instead of writing that logarithm repeatedly, we can write the variable which refers to this logarithm. And I have taken the example of log of 5 to the base 6. So the argument and the base both are numbers. But I am not saying that the given logarithm will be containing only numbers. It may contain a variable as the argument, or it may contain a variable as the base, or it may contain two variables. Let's see what is given in our today's session, and we will be having 4 questions. We will be solving 4 questions in this session, and definitely I'll be asking you to watch my video completely so that you know this method of rewriting expressions in terms of a given variable or in terms of a given logarithm totally. Okay? So without any further delay, let us start with our today's session. Given that now I had said let t equal to log of 5 to the base 6, but this time in this session we are seeing that it is the variable is not equal to t, it is u. U equal to log of x, the argument is a variable and the base is a number. It is u equal to log of x to the base 5. Whenever we have to write log of x to the base 5, in fact, we have to rewrite the expressions in terms of log of x to the base 5. But instead of writing this term every time, we will be writing u. Okay? Find or write the following in simplest forms in terms of u. Question number 1. It is a simple x. It is a pure algebraic expression containing a single term. It is x. And we have to write this x. We have to rewrite this expression which contains a single x in terms of u. So how do we do this? We start with this given equation and we write this equation, this side first. Just for the sake of the easiness of conversion, because it is an equation, doesn't matter which side you write first. And actually I have written this first just for the students who are watching my videos sequentially, they know about the BAP and the BPA rule. For logarithmic equations, it is the BAP. B stands for the base, A is the argument, and P is the product or result. And if we have to convert it to an exponential form, the B remains the same, the base remains the base, the argument becomes the answer, and the product or result becomes the power. So the logarithmic form is BAP, the exponential form is BPA. So if we convert this to its corresponding exponential equation, what do we get? 5 to the power of u is equal to x, or x is equal to 5 to the power of u. Now you see, in place of u, I could have written 5 to the power of log of x to the base 5. X is indeed equal to 5 to the power of log of x to the base 5. If you have gone through my video on 4 important properties of logarithm. You should be knowing this. And but instead of writing this whole term, we can write 5 to the power of u, because we have written that u represents this term, this logarithmic term, log of x to the power to the base 5. Okay, so this is our final answer. X can be written as 5 to the power of u. Coming to question number 2. Log of x over 25 to the base 5. Again, it is a single term expression, but this time it is a logarithmic expression. Okay, so and we have to rewrite this expression rather in terms of u. So we are having log of x to the base 5 equal to u, and x is in the numerator. Therefore, we have to first of all expand this using the division law or quotient rule of logarithms. We expand this and it becomes log of x to the base 5 minus log of 25 to the base 5. And this is straight cut. We can write u in for this term. This is equal to u, and what happens to this term? 25 can be written as 5 to the power of 2. So it is u minus log of 5 to the power of 2 to the base 5, and this 2 can be brought down to the coefficient position. So it is equal to u minus 2 times log of 5 to the base 5, which is equal to 1. So this is equal to u minus 2. Okay, so this single logarithmic expression, which contains a single term, can be written as u minus 2. That is log of x to the base 5 minus 2. Okay. Coming to question number 3. Log of 5 times square root of x to the base 5. Again, a single term expression, and this single term is a logarithmic term. Again, we will be expanding this expression, because we need this log of x to the power of to the base 5 part, so that we can write u in place of log of x to the base 5. So we have to expand this using the product rule. So this will be equal to log of 5 to the base 5 plus, because these two are connected by multiplication sign, so it will be plus log of square root of x to the base 5. And square root of x, I have said before in our previous sessions that you cannot do any modification when the given argument is in a surd form. So first thing that you have to do is you have to convert it to its corresponding exponential form. This will be x to the power of half, and this is equal to 1. Log of 5 to the base 5 is equal to 1. So this is 1 plus log of x to the power of half to the base 5, and this half can be brought down to the coefficient place. It is 1 plus half times log of x to the base 5, and this part is equal to u, so it is 1 plus half times u, or 1 plus u over 2. Okay. Coming to the fourth question, log of x times square root of x over 125 to the base 5. Again, a single term expression. It is a logarithmic term, and again we have to expand using the division rule or quotient rule. And first of all, we have to simplify the numerator, because this is x times square root of x, and we cannot keep this square root, the surd form. We have to convert it to its corresponding exponential form. So it is, first of all, okay, we have expanded log of x square root of x to the base 5 minus log of 125 to the base 5 using the division rule. And what should be done to this part? It is x to the power of 1 times x to the power of half, because square root of x is equal to x to the power of half. So x to the power of 1 times x to the power of half, what is that equal to? It is x to the power of 1 plus half, which is 3 over 2. Using the multiplication law of indices or exponents. Okay. And this 125 is 5 to the power of 3. And this 3 can be brought down, and 3 over 2 should also be brought down to the coefficient place. So it is 3 over 2 times log of x to the base 5 minus 3 times log of 5 to the base 5, which is equal to 1. And this part is equal to u. So it is 3 over 2 times u minus 3. Okay? Or 3u over 2 minus 3. So these were expressions containing only a single term. We are learning the logarithm chapter gradually, so it is obvious that first of all we will be taking up simple questions and gradually we will be moving to the more difficult ones. Okay? So students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.